welcome guys. So keep solving our physics subject GRE. So for 31 and 31, I already solved this kind of type of question many times. So which should remind us that the positronian is really important in this physics subject GRE. So I would just tell you the answer, but I just so the difference for the positronian is since you replace the proton to the positron, so the effective mass of these two is half of the original. So basically, the hydrogen atom has this, and the positronian is just this divided by 2. So this is the formula for the positronian. So what you ask about the energy of photon from n equal to 1 to n equal to 3. So this is your answer. Just okay. So answer is A. Answer is A. Just by computation, we can get 6.0. Okay, so 30 total energy or mass equal to twice of rest energy. So E squared m to the c to the 4 plus p squared c squared. So this is 2mc squared to the twice is m this one. Okay, so ask about magnitude. So basically it's about p. Okay, so we can compute p is just square root of 3 mc. Okay, so the answer is D. Okay, so 33, a charged pion decays 10 to the negative 8 seconds in its own rest frame, and to travel 30 meters in the laboratory before decaying, and power speed must. Okay, so this is the common question. So 30 is just Vt, but remember the T will be shrink. Will be a dilation, so you can solve this. Okay, so this is the time dilation. Okay, and just directly solve V, and what we can get is D. V is close to 2.8 times 10 to 8. This need just directly square and solve it. 2.98. 2.9, so it's very close to C. So the answer is D. Okay, so 34. Two events occur at x and is separate delta t and the space in delta x. Okay, so basically what I need to say is delta x squared minus c delta t squared is constant. So at a different times that the two events could occur at the same time. So occur at the same time under which. Okay, so under at the same time means that whenever delta x is this must be 0. I told you this must be larger than 0, which tells that delta x must be larger than divided by delta t must be larger than c. Or this is called somehow called okay, space-like events. Space-like event, because space is much larger. So the answer is C. Or basically you don't have to know anything. All you need to know is this distance is invariant in the Lorentz transformation. Okay, the black body temperature is 3 times. So basically what you have is the Stephen's law. Stephen's law tells you power is proportional to the temperature force power. So the answer is the increased factor of 81. Okay, so the answer is E. Okay, so 36. Consider the quasi-static adiabatic gas from I final which the following statement is not true. So first one, no heat flows in or out of gas. Then this is called adiabatic. this is a definition of the adiabatically. Okay, B, entropy is the same. This is basically also the definition of adiabatically. Okay, C said that the change of internal energy of the gas is that. This is the first law because the change of the energy is basically heat minus the work, and heat is 0, so PDV, which is the work, and then D is a common sense. So the rest is just E. In temperature means remains constant. This is called isothermal process, not adiabatic process. So the answer is E. Okay, 37. I ask you about what? The work. The work is just the area of this diagram. So what we need is just easily compute the work. So the work is just this area. And so actually we don't know how to compute this area unless we know. So first we need to find this volume. So so C is the isothermal process, right? So that means 500 times 2 is 2 times is 200 times something. So which is 5. So V is from 2 to 5, 200, 500. So area for this is 3 times 300 divided by 2. This is a triangle area. Okay, so remember that what we want to compute is not triangle, but we know that this area must be less than this for 450. So which one is less than 450? It's only 300. So we need, and we know the answer must be B or D. But finally, what we want to ask is what is the work? Is positive or negative? The work is positive or negative? Okay, by the graph, the work is negative. Okay, basically you can see the cycle directions. So the work is negative. Okay, and then if the direction is reverse, then work is positive. Okay, so the answer is D. Okay, let me see. So we start from 31. Okay, so 38. You know R, you know L and C, and somebody at what value C is amplitude, current maximized. This is standard. The resonant frequency is 1 over square root of LC. Basically, you need to remember this formula. Okay, so you can plug everything in. So you know the omega is 1000 radians, and 1 over L is millihenries, and C. Okay, so we get the answer is D. Just direct computation. Okay, which one is a high pass filter? If you know the electronics, then I will tell you. I can give you the quick answer. Okay, so electronics, basically the common sense is that when omega is very small, then capacitance is open. C is open. Omega to infinity, then C is short. And then this is different from, this is just reverse from the inductance. So for inductance, if your omega is very high, then there will be so much inductance in the so much magnetic induction in the inductance. So the inductance will be open. And the omega is 0, then the inductance there's no any change in the inductance, so it looks like a short open. And basically you can see by since the impedance for this is this one, impedance for this is this one. So you see omega to 0, this is 0, omega to infinity, this is infinity. So once you remember these two formula, or you have some physical intuition, then you know basically this is a common sense. Okay, so this table you need to remember. Okay. then start to do your electronics. Okay, so when omega is very high, then inductance looks like a what? Look like it's open, right? Look like open. So the first one look like open, and then there's 0 and V. Then what? Then why is this V out? Why is this V out? Why is it? The V out is 0, right? The V out is 0, since there's no voltage. Okay, so the first one is not correct because we want the omega. Well, we want the frequency is high, that V out is close to V in, then which is called high pass. So for the second one, when omega is very large, then this is open. Open. So this is V in. So there's means no current will come in here. So these two are V out is close to V in. So 2 is okay. 2 is okay. And the similar, you can see basically if you change inductance are somehow like a reciprocal of the capacitance. So if you change the direction, change the position of the resistance and the inductance, and change the inductance to the capacitance, then it must be the answer. So the 2 is the same as 3, 1 is the same as 4. So the answer is 2 and 3, 2 and 3. Answer is D. Answer is D. Okay, so remember this table. Okay, so 40, what we need is just solving the differential equation. Basically, this is RL current, RL circuit. And which one is the answer? Okay, nice. Somebody will ask you about what? Voltage across the inductors. Nice. Okay. Okay, so let me tell you the also basic facts of it. So basic fact. There are multiple ways. Basically, you can solve the differential equation. But since I know electronics, so I will teach you how to use the electronics fact. So T goes in a DC T goes to infinity. If you have a capacitance, then what? The capacitance will fill with the charge. So capacitance will become open. And when T goes to infinity, the inductance will become short. Okay. So finally, the inductance will become short. So there's no voltage will cross the inductance. There will be no voltage will go to inductance, right? So the answer is D or E. The answer is D or E. Okay, and what is this? What is this? So this is the half time. So the half time, basically the time constant, as I just said, remember is I remember it's L over R. So basically you have 10 divided by 2. Okay, so which is close to D? Answer is D. Yeah, so you don't have to solve differential equation in a subject GRE. You can use the common electronics understanding and then know which one is correct. Okay, thanks.